So section 7.2 is 3 whole word problems. But we have to introduce a new number to you. Way back at the beginning of this semester, we talked about pi and how pi is irrational because it has, it generates forever and ever and ever, never falls into a pattern of repetition, never stops. So we say it's non-terminating because it doesn't stop. And we say it's non-repeating because it never falls into some sort of repetitive number sequence. So those two qualities together make pi irrational. Well, there's an infinite number of irrational numbers, but we're going to do, and I don't know if you remember, the square root of any prime number is irrational. So the square root of 2, the square root of 3, the square root of 5, anything like that is irrational. So we've dealt with pi. Pi's job is to play with circles. Well, now we're going to play with E. And E's number, or E's is, his job is to play with money. Okay, so just like when we were trying to mess with circles and find their area, circumference, all that kind of mess, we came up with pi. Now what we have is E. And so when we start talking about money compounding, so if you're going to get a loan or an investment where your interest is compounding, what that means is at the end of every compounding period, they generate interest and it becomes part of the overall amount. So then in the next month, they'll generate that interest again. So you're paying interest upon your interest upon your interest upon your interest. So we found out, or actually some guy named Euler found out that the more frequently you compound, this lovely little number starts popping up. So if you compound continuously, which makes it sound like it spirals out of control, it doesn't, because then E all of a sudden comes to the forefront. So in 7.3 and 7.4 and 5, we'll have some more explanations as far as what those are. But or what E does, but for right now you just need to know E is a number, okay? And he's also a button on your calculator. You have a scientific calculator. I'm going to show you my graphing calculator just so you know. You have an LN button, which you cannot really see. La, 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 there he is. All right, so LN, which we're going to hit in 7.3, means the natural log. And if you'll notice right above it, it says E to the X. So we're going to be using E to the X, which for, in this case, it would be E to the first. Okay, so that's what we're doing. Anyway, just remember all of that to say that E is a number. It's not a variable. So for number 1, it says that the population of a certain inner city area is estimated to be declining according to a model P of T. So the population in terms of time equals, and then I got 452,000 E to the negative 0.014 T. And so T is the number of years from the present. What does this model predict the population will be in 8 years? So if you look at this, you only have one variable. This is a number. So I want to know what P of 8 is. So I've got 452. And then E to the negative 0.014 times 8. So what does order of operations say? Order of operations says I need to do the exponent first. So assuming you can see this, it's kind of bright and cheery, isn't it? Hang on, let me see if I can turn this off. Wait, does that help? No, it does not. Okay, whatever. What you have is a negative 0.014 times 8. Okay, and when I get that answer, I get negative 0.112. So 452,000 E to the negative 112. Okay, so exponent first. Well, now this exponent is only attached to the E, so I'm going to figure out what that answer is. So I get 452, and this is going to go ugly really quick. Okay, so I have E to the And then that answer is going to give me a big, long, huge decimal answer. How can I make you see this? Ha! All right, so 0.894044255. Okay. So e to the blah, 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 blah gives me, that was not what I wanted, 452000, and then this becomes 0.89 4044 2575. So now the only thing left to do is to multiply that times the 452. So times 452, 123, gives me 404108. So 404108 is the number of people that should be populating that inner city area after 8 years. So what did the problem say? It said it was declining. So something to notice is that declining meant that my exponent was negative. Okay, and that's going to be a fun little pattern that we hit on. If our exponent is positive, it's going to increase. Well, this is a negative exponent, so it's going to decrease. And then just follow it. That's literally as hard as this section gets, but we're going to go ahead and walk through the other two problems. So the function equals C sub O times 1 plus R raised to the T. That models the rise in the cost of a product that has a cost of C sub O today. So what I'm saying is C sub O. Okay, it's just C sub O. That means your starting number. So hang on, whoops, wrong one. All right, subjective to an average yearly inflation rate of R for T years. So inflation is going to hit, and then this is going to be the number of years that I do this for. So if the average annual rate of inflation over the next 8 years is assumed to be 1.5%. So here's what I know so far. 1 plus my inflation rate is 1.5%. Remember that that is given to you in percentage form. You need to change that into a decimal. And you're like, it has a decimal. No, it doesn't. I mean, it does, but no. All right, so if I multiply this by 100 to get this out of decimal speak, okay, my actual decimal representation is 0.015. So in percentage, it's 1.5%. In decimal, it's 0.015. Okay, so always make sure you change your rate into a decimal format. And then it says through 8 years. Okay. So over 8 years is assumed to be 1.5%. What will the inflation adjusted cost of a $33,400 car be? So I would like to know the cost of my car right now is $33,400, and I would like to know the cost as time goes on, or the cost in 8 years. Okay. So again, all of your variables are done. All you have to do is slap this in your calculator. So order of operations says I have to do what's inside the parentheses first. So I'm going to add the 1 and the 0.015, and that gives me 1.015. Then I'm going to raise that to the 8th power. Okay, so I get 1.12. So 1.126492587. So I added this first, then I raised that answer to the 8th power, and I got this answer, and now I'm going to multiply it times 33,400. And I get 37,624.85. So if my inflation is making the product increase, then that should make sense. So instead of paying $33,000 for a car now, I'll essentially in 8 years be paying $37,600 for pretty much the same thing, because inflation will cause it to increase. Okay, and then we have statistics show that the fractional part of a pair of flashlight batteries, P for pair, that is still good after T hours of use is given by P equals 4 to the, so P equals 4 raised to the negative 0.02 T. Okay. What fractional part of the batteries is still operating after 200 hours of use? So remember, this is going to be declining because you've got a negative exponent. So your batteries are all nice and fresh and pretty right when you shove them in there. Well, after 200 hours of use, what percentage is still available? So that means we're going to have P of 200, and that's going to give me negative 0.02 times 200. So order of operations, I don't have parentheses other than this for multiplication, so take care of your exponent first. So negative 0.02 times 200 is going to give us a negative 4. So 4 raised to the negative 4 power. And then 4 raised to that is going to be 0.00390625. Now, does it say, all right, it says as a fraction or rounded to 6 decimal places. So if you want 6 decimal places, there you go. If you wanted it as a fraction, then remember that this negative says drop that to the bottom. So I would have 1 over 4 to the 4th, and 1 over 4 to the 4th is 1 over 256. Okay, so either way, those two answers are the same. They're not perfectly the same, but they're average the same. Now, this is also where you're going to want to come when I introduce the project, because these types of problems are going to help you finish out the project. So when I give you the video for the project, I'll tell you to reference the video for 7.2. So that's what I'm yapping about when I do that.